Hello friends, welcome to Joy of Life. So today we are going to look at a hard problem from Leetcode. The problem number is 76. The name of the problem is minimum window substring. So the description says given two string S and T, return the minimum in window in S which will contain all the characters in T. If there is no such window in S that covers all characters in T, return the empty string. There is a note given. Note that if there is such a window, it is guaranteed that there will always be only one unique minimum window in S. So this is the problem, and we are going to look at some of the examples given by them and try to understand the problem in more details. So here we are given with the input, two inputs. One is Adobe Code Bank, which is the input S, and the input T is ABC. So we need to find out the shortest window in S, that is Adobe Code Bank, where we have ABC present. So if I take this input string over here, so you can see over here that ABC is present in this substring. We have the A, we have B, we have C, but it is not the shortest one. The shortest one is over here, B, A, and C. So you can see here that we still have A, B, C inside this, and the size of this is 6, wherein the size of this is just 4. So we need to find out the shortest one. So our answer should be in this case B, A, and C. As you see the same over here as well. And there is another sample input given that I am given with a string A and I'm looking for A, and the shortest string is of course A. So this is a hard problem, but as always I recommend that you give it a try yourself. The solution is a little tricky, so just give it a try yourself. You can pause the video and resume it back once you have a solution or once you have given a try to solve the problem. So let's move over to the board and try to solve this problem. So I've copied the input, both the inputs S and T from Leetcode into our board, where we are going to do a dry run and see how we can come up with the solution. So when I get a problem like this, when I have to find something in a minimum window, so we have to figure out the minimum window that we can find in this problem. So the approach that straight away strikes to my mind is a sliding window technique, and we are going to use a sliding window technique over here in order to come up with the solution. So let's see step by step how we are going to approach the problem and how we are going to solve the problem. So here we have two inputs, S and T. S contains a string which is the big one, in which we are looking for T, and we are looking in the minimum span of window. So what we are going to do is, first we are going to create a map. So I need to know when I have found all the characters that is present inside my uh, smaller input, which is T. So what I'm going to do is I'm going to create a map. So as you know that map stores a key value pair. So here my key would be a string and my value would be an integer. Okay. And what I am going to do is I am going to go through each of the characters and store their frequency. So in our case, the frequency for each one of them is 1. So A is there one time, B is there one time, and C is there one time. So this is my initial condition. And what we are going to do, we are going to start going through the string from left to right. So we are going to start from this index and go towards this side. And as I said that will be doing a sliding window technique over here. So few things are needed over here. The first thing that I need is in order to create a window, what I need is a left bound and a right bound. So we need two variables over here. Let's call them left and right. So here is my left and this is my right. And both are initialized to 0, right? And we are also going to keep a track of how many characters is remaining. So this is going to be one of the indicators that is going to tell me that how many characters is still remaining, how many characters I have already found and how many characters are still remaining. So let's say C char remaining, okay, which is like the total number of character that is remaining in the entire string. So to start with, it will be the length of my t. So I need to find out those three characters. I haven't found anything yet, and this is what I'm looking for. And also I am going to keep a track of my size. So size is going to tell me what is the minimum window that I have seen so far that contains all these characters, means all these ABC characters. And also I am going to store so we need to return BANC, as you remember from the uh, problem statement, that we need to not only return the size of the window but the content of the window as well. So what we are going to do is we are going to keep a track of the result also. So let's say this is my result. Okay, so size is initially what I'll do is I'll initialize with it to max. Why I am initializing this to max? The reason for that being we are looking for a shorter window. So I've initialized with the biggest possible integer value, and whenever I find a better result, I'm going to make it shorter. If I have to find the bigger window, then I would have initialized with 0 or min. So max means integer dot max value that I am referring to over here. And the result is initially we haven't found any result, so that's why I am going to initialize the result with a blank. So this is my initialization condition, and now I am going to start the traversal. So my left is at 0 and my right is at 0. And having said that, it means both the cursors are over here. And I am going to look at the character that is pointed by my right. So what I see is I get a character A over here, right? So 0 is the first character of the input string, which is A. So we are going to go and check that if my map contains a or not. I see, yeah, my map contains a. So what I am going to do is I am going to reduce the count. So we have already found a. So I am going to reduce this to 0. And I am going to update my char remaining to 2. Max size, I'm not going to touch it now. Result also I'm not going to touch it now because I haven't found the window yet. So what I do now is I go ahead and update my right. So what happens now is my window is extended. It is from here to here now. It comes to D, and we see that D is not in this map. So we move on. We move the right to 2. Now it comes to O, and we see that uh, O is also not present on the map, so we move on. We move to 3. So we reach here, and here I see that this B is present on the map and the count is 1. So I reduce it to 0 because I have found a B. So my window contains a and a B, and the character remaining is 1. Um, you can see that our character remaining is still not 0. When my character remaining reaches 0, that means I have found all the characters that I am looking for. Okay, so it moves on. It goes to 0, 4 now. And the character we get is a E, and E is not here, so I am not going to do anything. I am going to move on. I reach 5, and what I see is the character C is present on the map, so I'm going to consume it, and I'm going to say my characters remaining is 0. So this means I have reached a window wherein I have found all the characters that I am looking for, and this is a eligible result. As of now, my size is set to max, and what I see is I am getting a better size. So what I see now is we are getting a window of 6 characters. Right, so our formula over here to get the size, I'll just put it over here. So size, how we are going to calculate whenever we have a size, we are going to do a math.min between my size, the size that I already have, and I am going to take right, my right minus left plus 1. Plus 1 we are doing because it's a zero based index. So what we see is we get a 6 over here. So we are going to put 6 over here. And what we are going to do at the same time is we are going to get the substring from 0 to 6. This substring that my window is currently pointing to. So I get a result ADOBEC. Okay, so whenever the count comes down to when the char remaining comes down to 0, I know my right is pointing to a char that is required for me. So I am going to minimize my left and keep checking that can I make this window any shorter. Okay, so what I am going to do is I am going to move move this left now, since my count char remaining is 0. So I will be releasing anything that is being held by the left pointer. So left is pointing to A at the moment. So what I'm going to see, I am going to check that is A present over here. If yes, I am going to update the value and I am going to give him back 1 because I have moved a character, and my right remains at the same place. And since it is one of the characters that is present on this map over here, I am going to add 1 to it. So what happens in this stage is I get a window which is this big, which starts from D, and straight away I see that this window does not contains all the character that I am looking for because my char remaining is 1. So what we are going to do is we are going to move on, and keeping this once fixed, we are going to we will again start moving our right. So now it comes to this window. We see that O is not a character that we are looking for, so we will keep updating our right side. We'll keep extending our right side. So we get a D now. So D is also not what we are interested in. So we update this value. Let me update this first. And it moves to E. We move to E, and E is also something that we are not interested in. Now this is a pretty interesting scenario that I get another B, and B is already something that we have consumed. But what we are going to do when we still get a B is we are going to decrement this value even further. We will take this down to -1. Okay, but we are not going to touch the char remaining because this is an extra character that we have found, but it might be useful for us later, but not at this point of time. So we move on. And you will soon see that how it will start making sense. And what happens is this moves on, and I get a A, and what I see is that we have a A, so we should go ahead and decrement it. And what happens is char remaining comes down to 0. And what we see is that the size of the window that we are getting is a 10 minus 1 plus 1, which is 10, which is not better than the window that we already have, which is a 6. So we are not going to update our size, or neither we are going to update our results. So we know we have a better window. So what happens is we start moving our left since char remaining has come to 0. So we come here now. And before we come here, just to mention that we will see that D is present here or not, or and we'll try to give it back. But yeah, D is not present here, so nothing is required. So we move on. So similarly, O is also not here, so nothing is required. So it moves on. Now you will see the interesting part over here. So I come to a window wherein I have a B. And mind, in all these cases wherein I am moving my left, I am comparing my result, but since my result is not any better, so I am not talking about them. So we'll talk again when we have a better result. And over here you can see that we have a B. So what we do is we are leaving this B now, right? It will be released by this character. So what we are going to do, we are going to remove this and put it to 0. So what happens is this comes to 4 and 10 now. So even if I left a character B that we are looking for, but I know I have another B, that's why my count is 0. That's why we took the value to a negative value. We allowed the value to go back to negative, but we are not allowing that in case of char remaining. Okay, so again what we see is we have a result like 10 minus 4 plus 1. So 10 minus 4 is 6 plus 1 7, so which is not better. So I'll keep moving my indexes. So what I get is a E now. It is a E now, and since E is of no interest to us, no, okay, we are at okay, we have left the E. Now we are going to leave the C, and as we leave the C, you can see that C is at 0. So we are going to give back C. So C will go to 1. So as we see that C is getting released over here. So what happens is I have a window. I have left the C and I have this window now. And since I have left the C over here, so this is 6 actually, 6 and 10. So what happens is my char remaining came back to 1. So I have one char that I'm still looking for. So currently, if you see over here that we are in this window ODEB, ODEB, right? So what happens is now we again start stretching our right. So this remains at 6 and this goes to 11. We get this window and wherein we see a n. So n is of no interest to us. So this goes to 6 and this goes to 12. We have reached this window now. The character represented by this window is a C, and we are going to decrement our C to 0. And our char remaining also comes down to 0. Okay. Again, we are going to make a check. So 12 minus 6 is a 6, 6 plus 1 is a 7. And we have a window of 6. So we are not going to consider it. So now I go to 7, 12. 7 and 12. So as I move to 7, I left O and O is not present on this map. So over here you can see that going by this formula over here, we get 12 minus 8, which is 4 plus 1, which is 5. And it is better than my current max that we have. So I update my current max and the value that we store over there is EBANC. So EBANC. So you can see there that this is of 6 character and this is of 5 characters. So we will continue to explore for better results. So I go to 912. So when I go to 912, this is my window and the character left by us at this point of time was a E. So I have a better window. I can get 9 minus 12 minus 9, 3 plus 1, 4, and the window that we can get is a BANC. And then I continue. So this goes to 10, 12. So 10, 12, what will happen is the character B will be returned back. and our char remaining goes to 1. And what we do is we increment our right and left remains at its place. So as we increment, we see that we are going out of bound. So you can see here that this is the end of the string where we are at the moment. And this is where we terminate. And our answer is already stored in our result and we return it. So you can see here that at every step how we are adjusting our left and right bound in order to come to the right solution. So basically, if you observe this problem, so this problem is about just adjusting your left and right boundary based on several conditions, and at the end we will have our result with us. So let's head over and put it in code and see how it goes. So we are going to put, as we have discussed, we are not going to do anything extra apart from what we have discussed. So to start with, we have the left pointing to 0 and the right pointing to 0. And so what we did first is to create a map of characters and the integer where we are going to store the frequency of each of the character. So let's name this frequency, and let's have a hash map. So what we are going to do is we are going to iterate over the t string, and we are going to store all the frequencies that we find in on that string. So we are going to do a t dot length. So we are going to go over this entire string. So what we'll basically do is we'll first get the character, each of the character out from uh, t dot, let's say char at I, and then we are going to see what is the existing count on them. So to do that, might happen that we it might happen that the um, character is not present on the map itself. So we are going to do a character get or default, and let's default it to 0, and we are going to put this frequency back into the map. So let's say ch and count plus 1. So this will create the map for me, which will have each of the characters and how many times the character has occurred in the string. So we'll have a char remaining as we have discussed, which will be set to t's length. So initially it will be the length of the smaller string t, and we'll also need to keep a track on the size, and as we discussed, we'll put it to integer dot max value, and we are going to minimize it, and what we are going to need is a result string wherein we'll have our final result. So at the end, what we are going to do is we are going to return this result back to the calling function, and we are going to iterate. So iterate mostly for all iteration on the sliding window is uh, your left should not cross the right and your right should not cross the strings upper bound. So let's say left less than equals to right, and then right less than s dot length. So this is my usual condition over here, and each time let's get the char out from the s dot char at right. So we are going to always get the character pointed by my right variable. Okay, so what we are going to say is if my frequency contains key. So first we need to see that if at all uh, first, we need to see if at all my map contains the character that is pointed by my right? Otherwise, we are just going to extend my right bound. So if it does, so we are going to, Okay, so once we have the count, what we are going to do is we are going to put the count back to the map again by reducing the count by 1. So here we are not having a check. We will allow negative values to go inside the map. But we are not doing that for chars remaining, right? So what we'll do is if count is greater than equals to 0 only, in that case only update our count remaining. So if you remember from our dry run, I'll just give you a quick glance of it. So here we always allowed the negative value to go in the map, but here we never did it. Once the char remaining is at 0, we never reduced it any further. Count is less than 0. That means the char remaining will go to negative, and we are just going to stop it. Okay, so this is the processing, and what else? Any point of time, if my char remaining is 0, that means we are we are currently standing at a substring which contains all the characters that I am looking for. And as you remember that we have the size is our marker, which tells me that is it of any better size or not. So what I'm going to do is I am going to check my right minus left is less than size. If it is any better, then only I am going to go ahead and update my size. Then only I am going to go ahead and store my right minus left. Right? And we are also going to update the result. So result is nothing but s dot substring, and we know what we want. We want from the left, and we want right plus 1. So we'll start the substring from the left bound, and we will go till that many characters. So since it's zero based index, so I am doing a plus 1 over here. Okay. So if you remember, there are two things happening when the char remaining is 0. One is we are not going to change our right, so our right will remain fixed and our left will change. So right will get processed again, and keep in mind the right is not getting incremented. So what I have to do in order to suffice this problem is I have to give back. So since I am not updating my right and the right is going to get processed again, so I am going to just put back whatever my right is holding. So suppose you have come to a string where you are looking for ABC, and you have found the match. So what happens now is right will not move any further. And when the loop comes again, so the right will get processed again. So to nullify that, I am giving back whatever is held by right. So I'm simply giving it back to him. So, and what happened is now we have to find and what happened? So right is not moving, but left is moving. So we have to give back what is being pointed by the left marker. So let's say this is my left ch, and left ch is nothing but s dot caret left. So if so again we need to check if my frequency map frequency dot contains key. So I'm going to see if it is having the left ch. So if it has, then I have to give it back to him, right? So what I'll do is in a temp variable, I am going to get its frequency, or yeah, frequency dot get of left ch. And what I'm going to do is I'm going to put it back by incrementing it. So I'm going to put 10 plus 1. So two things happening over here. Right, I am adding back so that again on the next iteration it does not duplicate the work. So it is going to process the right again. So it's going to do all these operation again, right? So I am just nullifying this operation by giving whatever is pointed by my right, since right is not moving. And since left is moving, I am giving back what is being held by left. So I am giving it back over here. And again, if temp is greater than or equals to 0, then I am going to change my char remaining, right? So we are not going to update our char remaining all the times. So if it is a value less than 0, so if you remember when we got a duplicate B, we have incremented from -1 to 0 over here, but we have not updated our char remaining. Since the value was less than 0, so we did not touch our char remaining. So that check is being performed over here. Okay, and what I'm going to do in this case, what will happen is uh, our left will be moved and nothing will happen to our right. But in other case, what will happen is our right will just move on. Nothing else. We'll just increment the right and keep finding our result. And at the end, what we are doing, we are returning the result, right? So this is the code. Let's see. Let's run it and see how it goes. I messed up something. 47. Yeah, something bad. Typos. I'm good at that, making typos. Oh my God, too many errors. Spelling is wrong, put is missing. I was busy talking. I'm sure there will be more. Oh no, okay, it's being accepted, and you can see that we got the output that we are looking for, and we got it done. So let's do a submit and see how it goes. We got a wrong answer. Okay, my bad. I have made the check on the count, but while putting only I have done a -1, but while checking I have not done a -1. So let's do something. We'll just reduce it directly over here and let's put it this over here. Let's run it once more and see how it goes. So you got what I did, right? I did a subtraction, but while checking I did not perform on the right value of the count. So yeah, it has been accepted, which is better than almost 40% of the submission. But yeah, as always, the main intention was to give you the idea on how to approach the problem and how we are creating a different sliding window at different stages in order to come up with the right solution. So I hope you like the approach. So this is a very optimal approach for an interview. There could be better approach, but it's very hard to think of a very optimal approach during an interview. So these kind of problem, what it will do is it will help you to identify the pattern and come with a quick solution. So even if you see this even if you see this problem, our complexity is not that high. We are just traversing over the T array once. We are creating a map with the T characters, and we are also traversing once uh, over the S string. So this is a pretty much optimal solution that you can give during an interview. And there is, of course, here and there you can refine it and make it better. So please like, share, and do subscribe if you haven't done so. Thank you once again for watching the video, and I'll be creating more such videos down the line. And have a great day. Bye bye.